A Lewis structure is a way to represent a molecule in which the valence electrons of all the atoms are arranged to achieve a stable electronic configuration for each atom in the molecule. For most of the atoms, this requires an octet of electrons. However, some elements require fewer than 8 electrons, such as hydrogen, which is stable with only 2 electrons in its valence shell. Some elements can exceed 8 electrons in the outermost shell. Those elements are in period 3 and below, but they will not be discussed at this time. The elemental symbols represent the atoms and are surrounded by these valence electrons, which are represented as dots. The shared electrons, or bonding pairs, are shown as 2 dots or a single line between atoms. The non-bonding electrons, or lone pairs, are placed on the outside of the atoms. For example, a fluorine molecule, F2, consists of 2 fluorine atoms, each with 7 valence electrons. In the Lewis structure for the F2 molecule, each F atom achieves an octet by sharing its unpaired valence electron. Other examples of Lewis structures are shown here. A Lewis structure for a molecule or polyatomic ion shows the sequence of atoms, the bonding pairs of electrons shared between atoms, and the non-bonding or lone pairs of electrons. In each molecule, the central atom, carbon, nitrogen, or oxygen, has a complete octet. In CH4, there are 4 bonding electron pairs to achieve the octet. In NH3, there are 3 bonding electron pairs and 1 non-bonding electron pair to achieve the octet. While in H2O, there are 2 bonding electron pairs and 2 non-bonding electron pairs to achieve the octet. Now determine the total number of valence electrons for Br2. Is it A, B, C, or D? The correct answer is D. Each Br atom is in group 7A and thus has 7 valence electrons. Since there are 2 Br atoms, there are a total of 14 valence electrons. We can also draw the Lewis structure of polyatomic ions. A polyatomic ion is a group of covalently bonded atoms that have an overall ionic charge. The plaster that is used to form the cast that protects your broken leg is made from a slurry of calcium sulfate. The sulfate ion, SO4 2-, is an example of a polyatomic ion. Let's draw the Lewis structure for the polyatomic hydroxide ion, OH-. Step 1 is to determine the arrangement of atoms. For a polyatomic ion, the atoms and electrons are placed in brackets, and the charge is written outside at the upper right. The hydroxide ion has a 1- charge. Step 2 is to determine the total number of valence electrons for OH-. Hydrogen has 1 valence electron, and oxygen has 6 valence electrons. The -1 ionic charge contributes 1 electron to the total. There is a total of 8 electrons, or 4 electron pairs, for the hydroxide ion. Step 3 is to attach each bonded atom to the central atom with a pair of electrons. Step 4 is to use the remaining electrons to complete octets. There are 6 electrons, or 3 pairs, remaining. The remaining 3 pairs are added to oxygen to give the Lewis structure of the hydroxide ion. Oxygen now has a full octet of electrons, and hydrogen is complete with 2 electrons. Now determine the total number of valence electrons for the polyatomic ion SCN-. Is it A, B, C, or D? The correct answer is C. The sulfur atom has 6 valence electrons. The carbon atom has 4 valence electrons. The nitrogen atom has 5 valence electrons, and the -1 ionic charge is another electron. The total number of electrons for this ion is 16. Let's try one more example of drawing a Lewis structure. Draw the Lewis structure for formaldehyde, H2CO. Step 1 is to determine the arrangement of atoms. For formaldehyde, carbon is the central atom. Step 2 is to determine the total number of valence electrons. Each hydrogen has 1 valence electron for a total of 2. Carbon has 4 valence electrons, and oxygen has 6 valence electrons. This results in a total of 12 valence electrons for formaldehyde. Step 3 is to attach each bonded atom to the central atom with a pair of electrons. A total of 3 bonding pairs of electrons, or 6 total electrons, are used to bond the hydrogens and oxygen to the carbon. Step 4 is to use the remaining electrons to complete octets. Since we used 3 bonding pairs of electrons, or 6 valence electrons, to attach the 2 hydrogens and the oxygen to the carbon atom, we have 6 valence electrons remaining. These are placed on the oxygen as 3 lone pairs of electrons. When we consider the rest of our Lewis structure, the hydrogens are stable with only 2 valence electrons, but the carbon is not satisfied because it currently only has 6 valence electrons, 2 from each of the bonding pairs. Because the carbon atom does not have a complete octet, it must rely on the oxygen atom to share one of its lone pair of electrons. This sharing of an additional pair of electrons results in a double bond between the carbon and oxygen atoms. Acetylene is used as fuel in some welding torches. In the Lewis structure, the arrangement of atoms for acetylene is HCCH. The Lewis structure for acetylene contains, is it A, B, C, or D? The correct answer is A. The Lewis structure for HCCH has 10 valence electrons. There is 1 triple bond between the carbon atoms and then 2 single bonds connecting each hydrogen atom to a carbon.